Hello everyone, and I'm back again with another video. So my name is Antoinette C. Pahanoy of ECE 3A, and I'm tasked today to discuss a certain topic for my performance task number 5 in ECE 23. Now let's go ahead and begin. I have here a quick learning objective about my topic, and I will be explaining to you the definition and importance of the CPFSK, how it works, and determine what actual electronic system uses CPFSK. For the definition, I have it here. So CPM, which is the phase of the signal, is constrained to be continuous or to memory. Like this is just a summary of the definition, but actually it's the information bearing signal frequency modulated, a signal carrier whose frequency is changed continuously. The resulting frequency modulated signal is phase continuous. So that's what you have see here. This is modulating wave digital, and this is the modulated result, as well as giving you some waveforms to better maybe understand a quick about this topic. Also, for a clear definition, it's a memory-based modulation scheme in which phase is constrained to be continuous. And this is what it looks like in a waveform. So this is where phase continuous FSK can be seen. Why it is important. So, as the name suggests, the phase of a CPFSK is in fact continuous. This attribute is desirable for signals that are to be transmitted over a band-limited channel, as continuities is in a signal introduce wideband frequency components. In addition, some classes of the amplifiers exhibit nonlinear behavior when driven with nearly continuous signals. This could have undesired effects on the shape of the transmitted signal. Also, I'm going to show you 6 plots, maybe to help you better understand what or how the CPFSK signal works. So I provided you first. I have here the figure 2.12, which is dated phase state of CPFSK. So in this plot, it shows a where it can be interpreted from the figure that the transmitted sequence is based on the direction the signal moves in, or the scope of the signal within the bit interval. So that is what it looks like here. And for the figure 2.13, it shows the physical state of the CPFSK, which is observed phase. The jumps in the physical phase state here, as what you have noticed, state are not discontinuities. They are wrapped with phase state but wrapped within the interval. So for these two figures or two plots, or the 2.12, 2.13 amplitudes are the normalized phase with respect to the 2.14 plot that I have here. Because the figure 2.14 shows the baseband, or the baseband CPFSK signal for the input use in the figure 2.12 and 2.13. So there's no discontinuities on this part for the figure 2.14 and are present due to the inherent memory characteristic of CPM signals. And here on the figure 2.15, this is the binary CPFSK passband signal. And that's what you have noticed that how the frequency changes based on the data given. So the data input will increase in A plus 1. We have just the same and will decrease on with -1 input. So moreover, the frequency changed is noticed to be instantaneous at the beginning of each interval and holds its value for the rest of the bit interval. So it's kind of continuous with the same bit interval going up and going down. Now I have here two figures. The last two, which is the 2.16 and 2.17. So the 2.16 and 2.17 shows the phase tree for this one and the phase tree list for this one of the CPFSK respectively. We emphasize that the phase transition in the state trellis diagram in 2.17 here from one state to another are not true phase trajectories. They represent phase transition from before the terminal observed states at the time instance. Alright, now I have here a clock, or what you mean this clock data synchronization, which is an example of an actual electronic system that uses CPFSK system. So as what we have known, the CPFSK is promising modulation format because it has a compact spectrum and its receiver sensitivity can be improved with differential detection. The CPFSK modulator is implemented by embedding two MZMs. What I've mentioned, it's the Mach Zinner modulator. in each arm of the main modulator. In the CPFSK modulator, synchronization between the clock and the data signals is required. Similar to the case of the pulse curver and data modulation in RZDPSK transmitter, which is also a delta modulation technique, which will be discussed from my other classmate, where the timing control between the sinusoidal clocks at what you have noticed at your house and the data signal is required to be enable a synchronous control that gives rise to continuous phase modulation. The delay between the clock and the baseband signals adjusted to achieve the optimal condition for the CPFSK modulation by monitoring its optical spectrum. The accuracy of the timing control required for the synchronization control of the clock is being still investigated. So the timing misaligned causes the phase discontinuity and the frequency shift and result in the eye closure of the received signal. So again, unfortunately, I do only have one example of an actual electronic system that uses CPFSK. Hope you were able to at least help this to understand better about CPFSK system. Now, I have here a quick summary of what I've just discussed with you, of course, showing you the six plots to better understand the CPFSK signal, where it is the memory-based modulation scheme in which phase is constrained to be continuous, and the clock data synchronization, which is an example of an actual electronic system that uses CPFSK system. Alright, so I guess that's it for today, and I thank you for watching and listening as well, and see you on my next video. Goodbye!